My name is Dominik Lewe, and I would like to invite you to my lecture called Data Science 101, where I will guide you through the world of data science with an overview on machine learning processes, managing data science project, financing it, and some fun facts about the world and trends in this world. Once again, feel invited to watch my presentation. Good afternoon, everybody. Are you able to hear me clearly? Okay, so as introduced, my name is Dominik Lewe. I'm a data scientist at Lingaro. Maybe a couple of words about myself. As I told you, I work as a data scientist during the day, but as an additional engagement, I also pursue my academic degree, a PhD degree at Warsaw School of Technology, where I focus mainly on artificial neural networks and all the work connected to this topic. A couple of words about the company where I come from. Okay, now it works. So I come from Lingaro, a company that is Polish-based. It has almost 400 employees right now. It was founded like in 2003 or 4. It has 13 or 14 years. Right now it has two offices, one in Poland, in Warsaw, and the other one in Manila, Philippines. But we are currently opening a third office in USA, in Cincinnati, and a bit of perspective on the services that we are providing. I am working in this part, data science and machine learning, but as data science is actually providing additional value to solutions, we also offer warehousing solutions, cloud solutions, big data, so the clusters and Internet of Things, but also some consulting services like user experience, business analysis, apps that are adjust to both PC and mobile, and so on. But coming back to the original topic of our presentation, maybe let me give you a quick walkthrough of the topics that I would like to mention today. So first of all, I would like to explain you what data science is, or maybe how we at Lingaro understand it, because data science is like a buzzword that everybody uses, and it has a lot of meanings. It's actually floating. I would also like to tell you something about the trends in data science, some fun facts, languages that are used. Then I will give you an overview of some machine learning algorithms. Then I will also tell a couple of words about how to manage a data science project, the financing of those projects, and again we will go to more interesting facts. It's actually a catchy title, Artificial Stupidity versus Natural Intelligence. But it will basically focus on state-of-the-art uses of neural networks or optimization algorithms to problems from real world. And at the end, I will share with you a some knowledge sources, and we will have, of course, a Q&A session. So, what data science is actually best explained by the skills that a typical data scientist should have. If you Googled just once data science, you've probably already seen this visual. These are three groups of skills: the math and statistics, the computer science, and subject matter expertise. So a typical data scientist should be able to answer questions by analyzing the data. So econometric modeling, for example, but also more advanced topic like linear algebra or matrix calculus to understand the methods that we use to train the machine learning algorithms. The other group of competencies, skills is connected to programming, where a data scientist should be able to somehow automate the analysis that he creates using his knowledge, but also to enable the analysis to the user. So, for example, usually at an organization, people tend to make decisions based on hunches. And we as data scientists should be able to convince him that the data-driven approach is a better one. And in order to do that, we can make some applications, POC, and enable him some interaction with this algorithm by selecting like variable he would like to use. And this can provide us a buy-in so that we, in the end, convince him to actually make the data-driven decision. And the last group of skills is the subject matter expertise. This one is actually a tricky one because this can either help us or prevent us from arriving at a good decision. Because on one hand, having some knowledge about the area we are analyzing can help us formulate hypotheses. So what should we be studying, what should we be analyzing? But on the other hand, having a lot of industry information can prevent us from looking at the topic with our eyes open and only focusing on the insights that are provided by data. So we might like discard something as an anomaly only because we know from previous experience that in the past it did not happen. But actually, what data says might be a better approach. So, some examples of what I just described, and some other skills that are also necessary for a data scientist are soft skills. So, the ability to explain hard, complex topics to non-technical people. Because no matter how good the analysis is, unless somebody makes a decision based on this analysis, it doesn't matter. And of course, teamwork, and here I can talk from experience. Data scientist is often a person who combines a lot of different departments. Because when we do an analysis, we need information from different departments. Like, for example, to analyze promotions, we need to connect with the sales department to get the information on promotional activity. At the same time, we need information from the financing department and accounting about contract rates that were given to the particular customer. We also need to contact the IT guys because they are storing all the information in their databases. So we are the one point that integrates all of those departments. And now an example of how we can combine those skills, like on a real-life example of linear regression. And by linear regression, I mean, for example, predicting the prices of a house based on some attributes of the house. So, for example, the square meters, number of bathrooms, number of rooms, and predicting the value of the property. So we can apply our knowledge of math and statistics to build an econometric model. We can select variables that we think are the best. We can use some automatic variable selection techniques. We can do all the tests, but we are only able to check like a small number of models. And when we apply the other skills, the programming skills, we are able to automate this process to check many combinations almost at the same time, just like automatically by the computer. We can like code the process in a way that it provides us with all the statistics, all the p-values, parameters, and so on. And in the time we could do 10 models, we receive 100,000 models. And adding additional level of skills, the subject matter expertise. So, for example, we are able to choose the model that best explains business logic. So, for example, square meters of the house should positively influence the price. The bigger the house, the higher the price should be. And if we have a model that works in different way, it's probably a bad one, and because it's useless from a business point of view. Okay, so now some trends and facts about the data science world. What languages can we use when we do data science analysis? This is actually an analysis that shows what are the job offers and what words appear in job offers, and we are searching for a combination of a language, Python, R, and so on, with phrases like machine learning or data science. So we know what the graph depicts, but what are those languages? Python is like a general purpose language. It's pretty fast. It has low entry curve, like not a steep learning curve. And in context of data science, you can only use like 3 packages, and you are good to go with Python. There's Pandas, scikit-learn, and NumPy. When it comes to R, it's a language that was written by statisticians, so it's less optimal in its core, but there are a lot of packages that help R make it faster. And when it comes to packages and R, there are like a lot of them. And I also wanted to tell you something about Java, because the first 2 languages were more like ad hoc analysis, whereas Java is more for production and deployment. It's a high-performance language used in like production applications, but it's not suitable for ad hoc analysis. So what I wanted to show here is that Python actually is at the top of the podium. R is the second one, and Java being the third one, and probably because of different use in the more production environment. One other language that I wanted to highlight is Scala, the light blue line, because it is a language that did not exist a couple of years back, and it only gained like popularity fast, and because it's a language that Spark is written in. So it's usually used in context of big data and high-performance computing. But different surveys tell us different things. Here I have a survey asking people what's their language that they are using and they know. And here, for example, R is the one that's at the top. And I have a suspicion here that R is one of the top languages because there is a huge community of people like providing information in the internet regarding R. Okay, maybe a couple of words about trends in the data science world. Data scientists actually were claimed to be the sexiest job in the 21st century. The demand for data scientists is actually skyrocketing. And why is that? Companies generate huge amount of information every minute. There's a nice visual here, the one on the black background, which shows what amount of data is generated each minute. So, for example, it's 2 million searches on Google, 72 hours on YouTube, and so on, so on. So the amount of the volume of the data is simply huge. And one fun fact from the data science world: the data scientists are like animals that crave for attention, and they like to search for fun stuff in the data. And here I have one. Somebody analyzed salary surveys, and he found that developers that use Spaces earn more money than developers that use tabs. And he published it like a funny story to get attention. And he was quickly overthrown by another scientist who found that this exact relation is because those developers that use Spaces contribute to open source. And when you contribute to open source and you use some portals like GitHub, you should use Spaces because everybody downloads the code, and depending on the editor that they use, tabs may be interpreted differently. And Spaces is like a safe way to go. Okay, but going in the clue of the lecture, the machine learning stuff. First, I would like to divide the whole machine learning world and machine learning algorithms into two groups. Here I have a X matrix and Y matrix, and by X's I mean, coming back to the example of the houses, the variables that characterize each house. So for example, square meters for each house, number of bathrooms, number of rooms, and so on. And by the Y, I mean the price of the property. So the first group of algorithms is the one that does not try to explain the Y, simply try to somehow help you understand the properties. So somehow group them, or in another way, help you understand the data. And the other group is the one that, based on the characteristics, try to help you predict, for example, the price. And the first one was called unsupervised. It's like training without a teacher, simply analyzing the data. And the other is supervised, so you have a target that you are trying to achieve. And maybe more details about each of the groups. The unsupervised learning, the examples of such algorithms are clustering and association rules. Clustering is a way of grouping observations that are similar, so that we can, for example, if we are a company and we have our clients, we can divide them into similar groups to offer them products that are more adjusted to their needs. And we don't need to adjust to each and everybody's needs, because we can optimize by offering something to a group that is very similar one to another. Another method would be association rules, and this is mostly connected to market basket analysis, and I will also tell you a couple of words about that in a second. Okay, so clustering. There are various algorithms of clustering divided into two main groups. Partitional clustering and hierarchical clustering. The partitional clustering, in partitional clustering, you need to select the number of clusters at the beginning of your training. There are various ways of doing this, but you need to have this information before you start doing this, before you start the algorithm. There is one method that I wanted to show you. I don't remember the exact name in English, but it's like in Polish it's doesn't matter how it's called. What we want to see here is how many clusters we need, and we find this information by looking at the sum of squares from the center of the clusters. So when we have one cluster, let's look at the data. If we had one cluster somewhere in the middle, the sum of distances squared from the middle of the cluster would be huge. And this is what we can see here. If we add an additional cluster, one would be somewhere here, the other one would be here, the sum of square changes. And we choose the optimal point by selecting a point where this curve becomes like it's not steep anymore. And actually I have here an example for 4 clusters where we can see that it's not maybe the best approach because there are 2 evident clusters in the data, one here and one here. And that's probably the right number of clusters that we should select in this example. The other method being hierarchical clustering, it's more about finding the distance between the data points, and it can be done in various ways using like Euclidean distance, Manhattan distance, and so on. And we try to somehow build a hierarchy tree, and we can later on divide this tree in how many clusters we want. Okay, the other group, association rules, and as I said, it can help us in the market basket analysis. Those rules can help us make better decisions on, for example, which products are bought together with the other product. And using this analysis, we can actually make a list of products that are bought together with some information of whether it's a coincidence or not. But it's like a small area, so let's move on and focus on other stuff. When it comes to supervised learning, there are actually 2, again, a division between regression problems. So ones where we try to predict a numeric variable, so for example, the price of the house, and classification problems where we try to say, for example, what we can see on a picture. Is it cat or dog? So it's a classification problem because we are selecting labels. And when it comes to supervised learning, there are like 2 things I should tell you about. The first is that there are two phenomena that work one against each other, the bias and variance. Let maybe tell you something about it on an example. One more thing actually before I go into this. Usually when we train algorithms to either predict the price or predict the label, we usually use an approach that we divide our data set into at least 2 data sets. One that's used for training, so we can optimize the parameters of the models to better resolve the problem. And the other one is left aside. It's not used in training, and we use it as a validation of our algorithm, so that we can test what's the accuracy of the prediction on a sample of data that was not used in training. And coming back to the bias and variance, each algorithm tries to optimize both of those like phenomenons. And the bias is the one that tells us how well our model is able to fit to the training data. And the variance is the ability of our model to generalize the predictions. Okay, and the example here. I have plotted a couple of points here. The underlying true distribution of those points is polynomial to the 3rd degree with some randomness. And the colored lines are polynomials of different degrees. And the experiment was to look how the bias and variance changes when we introduce another like level of polynomial. And here is like a summary. Here we have the error that we achieved, and that the black one is the training data, so the one that we put into the model and we train on it. And the red one is the one that the model that did not see. And we can see that as we increase the number of the complexity of the model, so we add additional degree to the model, we can see that at the beginning both errors decrease. And after we pass the sweet spot and we know that this is the underlying true distribution, we can see that from that point only the training error decreases, because we are trying to fit to the data better, and we are actually doing it on the training data, but the error on the data that the model did not see starts to increase very much. So all in all, we are losing accuracy because our model is not able to generalize the predictions. And this is important because different models approach this trade-off differently. Okay, but going into actual models and the types of models, we have a whole group of regression models, like for example the linear regression, the one with the houses, logistic regression. It's basically a variation of linear regression where we add a link function to transform the linear input to the model to, and in this case the logistic regression uses the logit function, and more like business example would be predicting whether to give somebody credit or not, and this is a binary decision, 0 or 1. There is also the LOS, which is used to smooth points, more like weighted average, but also classified as regression. The other big group of algorithms are trees, so the decision trees. And decision tree is an algorithm that tries to divide the data into subgroups using features available in the data. So for example, in the case of house prices, we could use square meters as a variable that we could divide the data on. So above some level, we would get high prices, and below some level, we would get lower prices of the property. And as I said, there are a lot of variation of the trees algorithm. There is, for example, something called bugged trees. It's actually a shortcut from bootstrap aggregating, if I remember correctly, and it's basically training a lot of less complex trees and aggregating the results so that we get a more general answer. And here I did an experiment where I trained a tree to its maximum potential, and after that I started adding more trees in accordance with the bugging algorithm. And from what we can see here is that we were able to actually minimize the error on the test data set and achieve better results simply by applying this bugging algorithm. And this is because a single tree is not able to generalize well, and if we add more trees and average the result, we reduce the variance part of the error. There's also another variation of this called random forests, which introduces another degree of variation, because in backed trees we somehow randomly selected observations from the data set, and here we additionally randomly select variables to use. So it introduces another degree of randomness, and in practice it helps us reduce the variance error because it generalizes the prediction even better. And the third variation on the tree algorithm is the boosted trees. It's actually an approach where each additional tree tries to explain the errors that were done by the previous tree. So more weight is put on top observations that were classified incorrectly. So here we not only introduce another trees and this way decrease the variance error and we like help the model generalize better, but we also try to decrease the bias error. So at each level we are trying to explain why the previous model did something incorrectly, and this is why we reduce the bias of the model. And a short like summary of the three algorithms. So as I told you, boosting is the only one that can help you with the bias. Random forest and bugging are only making the generalization better. And generally with those algorithms you are not able to overfit. Maybe I did not said what's overfitting. It's a phenomenon where you adjust to the training data too much. And so you make the model too complex. It's like we could see in the polynomial example. When the model is too complex, we are losing the ability to generalize our predictions. And with these models, because either we are averaging the results or the models are simple, we are not able to commit this error, which is a good way. And like from industry experience, clients tend to like the boosting algorithm because on one hand it gives you very good results, and on the other hand it still has some it can still give you some explanation. Sorry. And whereas we will go into neural networks in a second, and neural networks can give you even better results, but as they are a black box kind of algorithm, they are usually not liked by the business people. Okay, so as promised, neural networks, which are currently like state-of-the-art algorithms, they give you the best predictions, and there are a couple of variations. The feed-forward neural network, which is the standard one. Here we have a very simple example of a neural network where we have our input. So, for example, the characteristic of a property, the meter squared, number of bathrooms, number of rooms. Here we have the output. So, is it an expensive house or a cheap one? And in the middle we have the hidden layers, the neurons, and the idea here is to somehow aggregate the signal coming from the input, multiply it by the weights which we train to achieve a good results, and then put it for an activation function which introduces non-linearity, so it helps us resolve the problem better. But there are also different variations of this, like convolutional neural networks. So networks that are best suited for image analysis, where we try to apply filters and extract high-level features from the image. And also recurrent neural networks, so best suited for text analysis. The one that is currently the best one is long-term, short-term memory. And to give you more intuition about the neural networks, I would like to refer to two examples. There are like nice web pages already provided to us by nice people at Google. And let's try to teach a neural net on the spot to describe, to predict this kind of data. We have two features, like two dimensions, and we need to predict whether the point is going to be blue or orange. And this website provides us like with an easy way of experimenting with. And here I, on purpose, selected a neural network which has one hidden layer and two neurons. Oh, sorry. That's actually a good comment. So I'm not able to see the screen here, which was before the presentation. Sorry. Okay. So I'm training a neural network, one hidden layer, when we are trying to predict this, whether the point is blue or orange. And we can see that having two neurons is actually not enough, because neurons transform the linear input into through an activation nonlinear function, and as an input we have only like a horizontal and vertical and horizontal, and using two neurons we are not able to somehow estimate which point is the good one. So it's some lag on the mouse, and I wanted to add an additional neuron to show you that adding additional one will like make the neural network instantly fit to the data points. There's actually one more web page that I would like to show you. Oh, sorry, I need to take this to my computer because I can't see what's there. Okay, so let's quickly train a neural network to, maybe let's also make a duplicate of this so that I can see it as well. Okay, so quickly train a neural network that is able to recognize gesture. And also an API, a web page that enables us to do the training. So here I basically gave her an input coming from my camera of me talking, and it recognizes this input and like gives us this nice GIF. But if we added an additional class, one where I, for example, take my hand up, we will see this GIF. So again, I'm not waving my hand, I'm waving my hand. We basically just trained a convolutional neural network, to recognize gesture and to react to what we are doing. Okay. Okay. So moving forward, another class of neural networks would be machine learning, the reinforcement learning. So one where we do not have the price of the house, the Y, and we are only trying to achieve like maximum reward. This is usually used in game playing, where we try to make the neural network act in a way that maximizes our rewards. And at this I would end the machine learning overview, and let's go into methodology of how to manage a data science project. There's actually a whole framework called CRISP-DM, Cross-Industry Standard Process for Data Mining. And this is like a methodology that gives us a nice overview of the whole process. It's actually a couple of layers deep, and at the top layer we have 6 phases, sorry. The business understanding, data preparation, modeling, evaluation, and deployment. So as we can see, it encompasses the whole process from actually going to the business and defining what's the problem that they are having and they would like to be resolved, to all the way to deploying a solution and thinking in advance on how to do it, how not to impact the business, how to validate it in real life. So that's encompassing the whole process, and at the same time, it's not specific. It does not tell you at this level how to prepare the data or how to model. This is somewhere deeper into this, in a deeper level of this method. And here I'm presenting like a overview of each of these phases. And even at the second level, this still is generic. So for example, in the data preparation part of the project, we have something about cleaning the data, constructing data, and so on. And given like a different data, so for example, the approach of handling missing values in numerical variables would be different than the approach that we would use to handle missing values in categorical variables. So this is still like on a lower level. So here we have a lot of details on how to manage the project without being specific or to a problem or an industry even. Okay. Actually, one slide that I did not have so much experience with, and my boss helped me, how to finance machine learning project and how to sell them to customers. So for sure there are European Union funds, but this is like a long shot. What might be more interesting is the proof of concept approach, because when we try to deliver a full solution, the minimum viable product and the minimum part usually grows to a level that is like beyond a month or so, and it increases the cost of the project. And what we would like to achieve with this proof of concept approach is small, lovable, and complete. So we want to provide the analysis and the insight, so the value to the business, not the data integration, the warehousing, and so on. So better to do something quick and dirty and actually to hook somebody on an idea than to do everything right from the start. Okay. There is also calculating a possible return on investment, which is a good way to quantize, dollarize the idea to people making decision. And another good approach is to sell data science as a value added to different projects. So for example, if we are doing a report in a BI tool and we are depicting like shares in the market or so on, we can add additional value using data science and try to sell it as a value added to this report, because we have already the data integrated, the visuals ready, and doing some analysis on top of that is simpler than starting all the way from the beginning. And the hardest way, the hardcore project, so selling only data science abilities and project. And this is the hardest approach. Okay, so the last big part of the presentation would be some usage of those machine learning algorithms and deep learning algorithms in actual problems from real life. And here I would like to show you a short movie on how deep learning was applied to ray tracing. This is a way of rendering images, and this is very computationally expensive way, because the ray tracing approach tracks each ray that is coming from the camera and tries to analyze what influences the color of the pixel here. So either this can be either the reflection or the color of the source of the light, the color of the reflection, or even if the sphere is somehow transparent, it can be the color of the object being behind. And here is a video from the NVIDIA conference where a guy explains on how they use deep learning to help them resolve this problem.
We also, in our company, we do a fair amount of deep learning research. Let me give you an example of what's actually happening. Basically, this network in the middle, this is just an articulation of the network, it's called an auto encoder. We're asking this network, if we gave it a distorted image of that, a noisy image of that it has to learn how to generate that image, the beautiful image, from that noisy image. The way that it has to do that, it has to figure out how to recognize the important features and eventually generate it automatically. Now, one of the areas we've applied this to is ray tracing. Ray tracing, as you know, is computationally incredibly intensive. Following photons around as we try to regenerate an image is very computationally intensive. And so one of the things we decided to do is what happens if we were to teach a network to fill in the spots that we haven't rendered yet. Okay? To generate some of it and to automatically infer or to use artificial intelligence to decide what to fill it in with. And so let's take a look at that. This is our ray tracer with deep learning. On the left, let's see. On the left here is without deep learning. On the right is with deep learning. Notice how noisy it remains for some time. With deep learning, it figured out, based on the surrounding things that it has already rendered, and based on recognizing what objects look like, what paint looks like, what glass looks like, it's learned those things, and it selected the right picture, selected the right colors to fill it in with, all by itself. And as a result, we were able to take this noisy image and turn it into a beautiful image. Is that amazing?
Okay, so basically here we could see an autoencoder. So it's a type of a neural network that was used to approximate what should be displayed around each pixel, given a distorted image, and trying, to as fast render the perfect image. But like another fun approach of using artificial neural networks, for example, style transfer. So are neural networks able to generate art? Maybe not yet, but here I tried to apply style transfer to an image from my holiday time, and I tried to make this image but look in this style. And what was the result? And here I used a convolutional neural network. Actually, it was a generator. I can reference you to the website. It's a Deep Dream Generator website which uses convolutional neural networks to transfer the style of an image. This is the result. It's not maybe perfect yet, but this basically has all the properties of the old image, but it adds the style from the image that we wanted to. And there are a lot of examples of this. For example, a boat and a sea and another style transferred here. Some landscape. A woman walking in a street, and the transfer that you wanted to, the style that you wanted to transfer are some skyscrapers. And another landscape. Okay, so this is one. And the other one that I wanted to tell you about is using neural networks for game playing. So actually, I here listed a couple of like monumental dates where algorithms beat humans in their fields where they were experts. For example, a program called Deep Blue beats Kasparov in chess, even before 2000s. An algorithm beats people in Scrabble. The IBM machine Watson wins in Jeopardy, 2011. One that was recently very popular, the algorithm that beats an expert in the Go game, and Go is a very complex game, so even here the algorithm could perform better. And 2017, the algorithm actually beat professional poker players in a tournament in Texas Hold'em. So we can see that if we train algorithms to a particular aspect, particular area, they are able to be better than humans. But this is not exactly the case that we always want, because who wants to talk with a bot that perfectly answers its question and seems very unnatural? People are introducing some errors in order to make the artificial intelligence more human-like. And there are like two examples of this. For example, in computer games, the algorithms that are responsible for the non-players' characters are frozen before the release of the game, so that we are able to beat them. What would be the fun if we were not able to beat anybody in the game? Okay, but those algorithms are only as good as the data that is provided to them. And if we train those algorithms on the data that is somehow biased, so for example, it has some stereotypes in it, or even the racism, the algorithms will only copy the behavior of the humans that collect the data or make the data happen. And here I have a couple of examples. For example, a camera suggesting if somebody blinked in the photo, or algorithm that adds sentiment to text. So sentiment is like a measure of whether this text is positive or negative. We can see that there are some stereotypes hidden in the algorithm, because simply typing let's go to get a nationality food, we get a different sentiment for different kind of food. So this is only as good as the data that is behind this. There are also some dangers to using this kind of methods if they fall into the wrong hands. Here I have another video showing how we can reenact somebody talking without them actually doing this. So this is like we could use this to make Obama speak something in a surrounding that he did not do it actually.
Given this audio as input,
it's been less than a week since the deadliest mass shooting in American history.
Our method produces the following output.
It's been less than a week since the deadliest mass shooting in American history. And foremost in all of our lives has been the loss and the grief felt by the people of Orlando.
Here's the ground truth video of Obama saying the same words.
Especially our friends who are lesbian, gay, bisexual, or transgender. I visited with the families of many of the victims on Thursday, and one thing I told them is that they're not alone.
To demonstrate the power of the method, we applied the same input speech mapped to 4 different target videos. Note that all 4 are synthetic and have different lighting conditions.
Auto industry. To help families refinance their homes, to invest in things like high-tech manufacturing, clean energy, and the infrastructure that creates good new jobs. Not to mention the job training that helps folks earn new skills to fill those jobs. The results are clear.
Because our approach requires only audio, we can generate a high quality hit close-up even when the original source video has low resolution or the gate is occluded.
We do one Christmas trip on Small Business Saturday. I usually go out there with the girls. And the last couple of years we've gone to bookstores.
Okay.
Because the nice thing about a bookstore is you can cover a lot of ground. You can get books for, the 6-year-old niece. You can get books for your mother-in-law. I think we're in a moment of history where kind of the most important thing we need to do.
Okay, you get the idea. In the video on the right, he was not actually saying those words. It was like manufactured by the authors of the algorithm. They tried to mimic the move of the lips and try to like recreate the face that he does when he speaks. So this could be a real danger if used in a wrong purpose. Another example of how we can what could be a danger is using like machine learning and advanced algorithm to, for example, get rid of the watermark. Here we can see an image on the left where that was published by one of the websites that provide photos, and they usually use a watermark to prevent people from illegally using the photo. And again, a group of scientists make it a case for themselves to try to remove this watermark in a programmatic way. Because you can do it using like Photoshop, but it's time consuming and you need to remake each photo individually. It takes a lot of time. So it's not actually a viable option, even if you wanted to get the images for free. But if you do it in a programmatic way and you automatically get rid of all the watermarks, you can make like a business out of it. Yeah, because those photos are no longer watermarked. Like the good thing here is that was a group of scientists who, along with the like way to get rid of those watermarks, also proposed a way of how to make them more impregnable, so that people cannot use this to their advantage. Okay, so let's also see.
Watermarks are typically added in a consistent manner to many images. In fact, we found that major stock content websites all embed the same watermarks in millions of their images. In this paper, we show that this consistency can be exploited to automatically infer the watermark from an image collection and to remove it from any image marked by it. We also propose solutions to address this vulnerability. We use a simple matting model, which is the one used most in practice. The unknowns are the watermark, its mask, and the underlying image. The watermark is assumed to be the same for all of the images. Here we show that as the number of images grows, a simple integration of the median image gradient gives a good estimate of the unknown watermark image, and that's used to initialize the algorithm. Here are results for images from well-known stock content providers. More are available in our paper and the supplementary materials. In all these cases, the original images can be recovered with high accuracy, automatically and without any user intervention, just by observing watermarked images on the web.
Okay, so thanks. It was a group of scientists who did this, because this could end up like losing the main business model for those companies providing photos via web pages. Okay, there are also some dangers of public data sets. Recently, maybe not recently, but some time ago, the New York City taxi company released the data on all the drives they had in the database. So the starting point, the end point, the fare, whether somebody tipped the driver or not. So this was anonymized data. You could not tell directly from the data who used the taxi, what were the characteristics of the driver. But people, like using data science and analyzing the data, arrived at some evil conclusions. Because they, for example, used this to stalk celebrities. Basically looking at the photos available in Google, they try to match the records in the database with somebody entering the taxi, and then trying to estimate where did he, actually not estimate, they knew where he went. Other analysis that I especially liked, because it was really, you had some invention to do it, is trying to find out who goes to nightclubs. And they did it like analyzing only the taxi drives that start from the origin of the nightclub between 12 in the night to 6 a.m. and like knowing who went from this point in the night, they could know where this person went, and if this appeared more than once, we could find a person who goes to nightclubs more often and more than once, and those are the blue spots. And actually, in some cases, the guy who made the analysis was able to determine exactly who the person was, like adding some information from Facebook and so on. So this can be dangerous, even if we do not, even if we make the data public that is anonymized, people can try to add some information and actually recognize people from this. But this is not only the case, this is not always the case. Some people use data for good, and there is a whole initiative called DataKind. So this is basically using data for good purposes. This is a non-profit organization, and the topics that they took upon themselves is, for example, creating safer roads. So they analyze data from street crashes, and they try to find what are the characteristics of a place where a lot of accidents happen, and they try to somehow resolve those problems to make the cities more safe. There is also a nice one, like forecasting water demand in places where there are a lot of droughts, and you need to import the water to make it available for everybody. And they actually optimize this process of importing the water by predicting better what will be the demand for water. And another one I liked a lot is the learning about homelessness. So understanding what leads to homelessness. And they did it by joining data from different non-profit organizations. One that took care of homeless people, and another one that provided some free consultation on different topics, both legal and life topics. And when they joined this data together, they found out what are the topics that often lead to homelessness. So they could try to resolve this problem in its origin. And with this positive accent, I would like to end the presentation and only give you like knowledge sources of where you could search for more information on the data science topic. First of all, I encourage you, to all the online courses that are available. The data science courses for sure there are abundance of them on different platforms: Coursera, Udacity, edX. The books, there are both books that refer you to those topics that I talked, but with a special focus on particular language. For example, machine learning with R, which does all the machine learning stuff using R. And there is basically a book for every language. Or more theoretical approach, so the theory behind the algorithms without the code, so applied predictive modeling, or I especially liked a book by Trevor Hasty, the Introduction to Statistical Modeling, I think. And there is also a Kaggle. I don't know if you know this web page, but this is basically a portal that helps develop the data science community by posting competitions. So they go into a cooperation with large companies, and they take problems for real life, like, for example, forecasting demand in bakeries to help the company better predict their demand. And they pose it as a problem to people all around the world. and they compete in trying to find the best algorithm to forecast this demand. And this is a really nice portal because it's, as I said, its target is to develop the community, so almost all the scripts are available. You can try to search for different approaches. Each of the winners of each competition has to publish his result, so this is also a knowledge source. And I really like this portal. And one more thing, I welcome you to visit the Data for Poland. For now, it's a place where like-minded people can exchange knowledge on data science, post some questions. We usually exchange the trends in the industry, but in the future, I see it as a data kind initiative, but in Poland. So trying to make something good out of the data here in Poland. Okay, so that would be it from my side. You have any questions, I'm more than welcome to try to answer them. I don't know everything, but I will try and do my best. Thank you. So, anybody?
Would you maybe share some of these slides?
Yeah, I will share it with the organizers, and I hope Magda will share it with everybody. Okay, so if no questions, thank you very much for your time, and I hope it brought some value to your life.
Thank you.
Thanks.